Hello everyone! In this video we will continue to examine topic 1.1 measurements in physics, and in particular we will unpack everybody's favorite topic, significant figures. Alright, significant figures. So there are a number of rules about representing values that I'm sure you were exposed to in chemistry. Usually under the name of significant figures or significant digits. Unfortunately, what most students end up walking away from their physics and chemistry classes having understood about significant figures is that sometimes you guess the wrong number of digits to put from your calculator on the test, and therefore you get half a point off. I am sorry that in general this is your experience. I'm going to do my best to make sure that this is not your experience in this class, because I'm going to do my best to explain why some digits end up being significant and why they're not. And I will also say that the most important aspect of this idea of significant figures comes from the meaning of significant figures, which is that some digits are more important, more meaningful, or meaningful at all than others. So some digits are meaningful, some are not. And this is incredibly important when dealing with concepts of uncertainty and error. When you actually take physical measurements, right? Some of the digits in the value that is being used to represent the physical quantity mean something, reflect your precision, and some do not. And so there's a set of rules about sort of how we deal with these values, and unfortunately where they show up the most often are in quiz and test questions, where you're already given values and then you manipulate them to find another value. But their most important significance, all right, their most important use is actually in actual physical data collection, the collection of the values in the first place. And so what I'm going to do is try to convince you and convey that the rules for significant figures relate to the meaningfulness that those digits have in telling you something about the actual physical world when you do the measurements. I will also back this up by saying I will mark errors in significant figures on quizzes and tests. You do need to know them. The IB is going to pay attention. But I care way less about your adherence to significant figures on quizzes and tests than I do on your labs, because that's where this really matters. Okay, so now there are a number of rules for figuring out how many significant figures or significant digits a particular value has. They're listed here. If you'd like to memorize them, that's not the worst idea in the world. But the way I would recommend getting a handle on significant figures is always coming back to the idea that significant means important or meaningful. And I would go through this list of examples here, and we'll go through them together, and just ask yourselves which digits tell you something about the value that is being represented. Because the number of digits that tell you something about that value are the number of significant figures in the value. So let's start with this basic number, 345, okay? The key idea here is that each one of these digits, the 3, the 4, and the 5, tell you something about the number. They tell you that there are 3 times 10 to the 2, plus 4 times 10 to the 1, plus 5 times 10 to the 0 of whatever it is. Let's say it's meters, okay? So let's say it's length. So there are 345 meters. Each one of those digits tells you something about the value that you're being given. And so each of them is significant. Now, what about this representation of the same value? This representation is 00345. Do these zeros, known as leading zeros, tell you anything significant? The answer is no. They don't tell you about the precision of the value. They aren't wrong. You could put them there. But they're also not informative. They're not meaningful. They're not important. And so this representation of the same number, which is 5 digits, 0, 0, 3, 4, 5, has exactly the same number of significant digits or significant figures as the one up front. Now, what about this value here? Right? This is not the same value. This is 3,045. What about that 0 right there? If we said these don't matter, does this one matter? The answer is yes. 3,045 is different from 3,245. So that 0 is telling you a significant piece of information about this number. That is, this number, as represented, has 4 significant digits, and that sandwiched 0, it's what they're called, sandwich zeros, counts. So this is 4 sig figs. Now here's the tricky one, the one that people have trouble remembering. Okay, so, well, really the next two, I would say, are the tricky ones. What about this 0 here, 345.0? Now notice, it's the same value as the one above it, as sort of our original value. It's 345. But 345.0 is actually telling us something about the next value. Here's where it matters. Let's say you rounded this number from the number you were given on your calculator when you did a calculation. Let's say it was 344.9178, etc. And you rounded it to this many digits. Okay? Well, then we're not sure what the next value is. This could be 0.2, for example, but only shown to 3 sig figs, to 3 important digits, right? So by putting this 0.0 here, you're actually telling your reader that we know what this value is. It's not 1, and it's not 8, and it's not 6. It's definitely 0. And so that 0 is meaningful. It tells us something about the value. This value is more precise than this one is. We know this one to more digits than we know this one. So this trailing 0, what's called a trailing 0, is significant, right? Now, what about this one? 0.34. Now, I will say this 0 is definitely useful. Like, unlike these zeros, this 0 has a use in that it draws our attention to the decimal point, okay? Please don't write your numbers 0.34, okay? Always include that leading 0 just for clarity's sake. But it doesn't tell us anything more about the value for the same reason these leading zeros don't. That is, this representation, 0.34, has 2 significant figures where 3 and 4 are the significant figures. That 0 is there because it's clearer, because it's more useful, but it's not significant in telling us information about the quantity that that value is representing. All right, so what about this number here? Well, that 0 is a trailing 0, just like the 1, 2 above it. And it's telling us that this next digit is not a 3 and is not a 9 or something like that. It's telling us something about this next digit. So 0.340 has 3 significant digits. This leading 0, again, is not significant. What about 2.00? Well, that's 3 significant digits as well, okay? In the next video, so those were the basics of significant figures. In the next video, I'm going to return to this topic, and we're going to talk about some of the most challenging cases of significant figures and significant digits.